mathematical modeling of global warming. These are the contents of our project.
Global warming is defined as a gradual increase in the Earth's temperature, generally due to the greenhouse effect caused by increased levels of carbon dioxide, CFCs, and other pollutants. We may not realize this, but global warming is getting worse and it has caused huge damage to climate change as we speak. So, what is the mathematical model of global temperature anomaly, and can we predict it in the future using this mathematical model?
The objectives of our project is to generate mathematical models using regression analysis and compare various regression models and choose the appropriate model to predict deviation in future global temperature average using the generated regression model. Lastly, to come up with a solution that will stop global warming and reduce the Earth temperature.
Global warming could be used for the estimated century scale within the average temperature of the Earth's climate system and its connected effects. Increasing or decreasing amount of greenhouse gases in the atmosphere add to either hold in or unharness additional of the warmth from the sun. Our atmosphere is getting hotter, turbulent, and unpredictable thanks to the boiling and cooling result caused by the heat-trapping greenhouse gases among the higher layers of our atmosphere.
The data for this project was retrieved from National Centers for Environmental Information website. The data used in this project is land and ocean temperature anomaly from years 1921 to 2020. Global temperature anomaly refers to deviation from an average temperature. A positive anomaly indicates the temperature was warmer than the average, while negative values were cooler. The data was then tabulated in Microsoft Excel. A simple linear regression model was generated since our problem only has two correlated variables, which are capital T representing the deviation from the average global temperature in Celsius and lowercase t representing time in year. Excel and SAS was used in developing our mathematical model. Excel was used to store and analyze all of our obtained data systematically. It was also then used to form a simple linear regression equation. SAS was used to generate a simple linear regression model in the form of capital T equals to beta naught plus beta 1 times by lowercase t, where the beta values are the parameters that will be computed in SAS using the proc regression statement. Both Excel and SAS form the simple linear regression as stated in the pictures, with R-square value of 0.8016.
Solution and analysis. This is the graph that was plotted using the scatter with straight lines and markers chart design in Excel. After using the trendline option, we get the best fit line in the graph. To ensure the developed model is valid, we find the t value for a particular t randomly using the model we have created and see if they are the same as our raw data or not. Based on the table, we can see that some predicted data similar to the observed data, and there are some that very different from the observed data. This corresponds to the fact that our mathematical model has a R-square value of 0.8016, which means that we cannot always expect that the predicted value to be same as observed values.
So, this is the result that we have obtained, which is simple linear regression model is a function t equal to 0.01012 times t minus 19.6 74380, where capital T represents the deviation from average temperature in a particular year, which is measured in degrees Celsius, and small t represents times, which is measured in year. Hence, we can predict the global temperature anomaly in the future by using this model. And we know that the closer the R-square value obtained is to 1, the better the regression line will fit our data. So we can conclude that R-square equal to 0.8016 indicates the data is fairly close to the regression line.